Hello everyone. Today we're going to talk about antiderivatives. What is an antiderivative? It's undoing the derivative, and it's also known as an indefinite integral. It helps us in solving problems involving area, motion, and accumulation. The general form of an antiderivative is integral of f of x equal the uppercase f of x plus c. The integral sign represents the operation you're working with. It shows that you are doing some integration here. Dx represents the variable of integration, and c is the constant of integration. Let's start with basic rules of antiderivatives with example on each. First, we have the power rule. The power rule is integral of xn dx. You just add 1 to your power and divide by the new exponent, so it's going to be xn plus 1 over n plus 1 plus c. Well, why do we include the c? Because the derivative of c is 0, so you have to make sure there was a constant here before you differentiate. Integral, for example, integral of x cubed dx, x power 3 becomes x power 4, and then you divide by 4. So the answer is x power 4 over 4 plus c. The second formula is the constant rule. Integral of a dx is ax plus c. Well, if you differentiate x, you will get back to a. So it's like you have to think what function gives me the a. From where did I get this a? Differentiating what? It's ax plus c. For example, integral of 5 dx is equal to 5x plus c. Some rule, if you're integrating more than one function, there's addition between them, so as if you are doing the integration separately and then adding the answers. For example, integral of x squared plus 3x dx is equal to x cubed over 3, so you add 1 here and divide by 2 plus 1, and for 3x also you add power, it becomes power 2 over 2, so 3x squared over 2, and for the 3 it's like a constant, so it doesn't affect my answer, just keep it as 3 over 2x squared plus c. Scalar multiple rule. So whenever you have a constant multiplied by a function and you're integrating, just take out this constant and integrate your function normally. For example, if you're integrating 4x dx, take out the 4 and then integrate the x power 1 dx. So it becomes 4x squared over 2. Sure, you have to simplify 4 over 2, and the answer is 2x squared plus c. Rule number 5, exponential rule. The integral of ex dx stays the same. It's ex plus c. For example, e power 2x dx is equal to e power 2x over 2. Well, why do we put over 2 here? Because the inner function is 2x and the derivative of 2x is 2. So undoing chain, you have to divide by 2. So the answer is e power 2x over 2 plus c. Rule number 6, logarithmic rule. The integral of 1 over x dx equal ln absolute x plus c. Well, this rule is very tricky, and most of the students, they do common error, like trying to integrate it as a power rule. But why does it fail power rule? Because if you're gonna add minus 1 plus 1 and divide by minus 1 plus 1, as if you're dividing by 0, so here power rule doesn't work. Well, every time you see a reciprocal, think of ln. Integral of 3 over x dx is 3 ln absolute of x plus c. Well, another question you would wonder of is why do we put the absolute value? Because the domain of ln is all positive numbers, so you know that x must be positive. And to make sure that this X is positive, just insert your absolute value. Rule number 7, trigonometric rules. The basic trigonometric rules, the integral of sine x dx is minus cosine x plus c. For example, integral of sine 2x dx is minus 1 over 2 cosine 2x plus c. Again, why did we put minus 1 over 2? I'm doing chain rule because you have the inside function is 2x. The derivative of 2x is 2. Integral of cosine x dx is sine x plus c. For example, integral of cosine 3x dx is 1 over 3 sine 3x plus c. Integral of secant squared x is equal to tangent x plus c. For example, integral of secant squared 4x dx is 1 over 4 tangent 4x plus c. Reciprocal trigonometric rules. The integral of cosecant squared x dx is minus cotangent x plus c. The integral of secant tangent x is equal to secant x plus c. The integral of cosecant cotangent x is minus cosecant x plus c. Well, yes, there's more and more rules. For example, the inverse trigonometric rules you can memorize. And let's practice. Let's do this exercise together. Integral of 3x squared minus 4x plus 2 dx. Here we have to do power rule, so it's going to be 3x cubed over 3 minus 4x power 1 becomes 4x squared over 2, and for the constant 2 it becomes a 2x. Don't forget to add your c. You can simplify the coefficients here, so it becomes an x cubed minus 4 divided by 2 is 2x squared plus 2x plus c. Well, let's do another example. Example 2, let's integrate ex plus cosine x. The integral of ex, do you still remember? Yes, it's e power x. What about the integral of cosine x dx? Yes, it's sine x plus c. Now let's do initial value problem, where you have to find out that c. For this, I should give you an extra given, a point to use after your integration to find c. Given that f prime equal to x plus 3, we should find f of x. So here, f of x is the integral of f prime of x dx. So if I integrate 2x plus 3 dx, this will be using power rule, a 2x squared over 2 plus the constant 3 becomes a 3x, and there will be a c, and this is f of x. Well, sure, you can simplify the coefficients. Now let's continue. F of 0 equal to 4. So if I want to find f of 0, or let's substitute x by 0, we will get, before we continue substitution, let's simplify the 2 here. So it's going to be an x squared plus 3x plus c. Back to our substitution, I'm going to make x, or I'm going to replace x by 0. So it's going to be a 0 squared plus 3 times 0 plus c. Well, f of 0 equal to 4, so I will replace f of 0 by 4, and then we got a 0 square is 0, plus 3 times 0 is 0, then c is 4. Now you just replace c here by 4. So your final f of x is an x squared plus 3x plus 4. That's the final answer. Well, now it's your turn. Find the antiderivative of 1 over x and leave your answer in a comment. Thanks for watching.